Hey guys, welcome back to Math from My Desk. And in today's video, we will be solving this integral right here. So we have the integral of 1 divided by e to the x plus 2 times e to the negative x plus 2, all with respect to x. So the first thing we're going to do to solve this integral is we're going to go ahead and multiply this fraction. Oh, sorry, I was on eraser mode. We're going to go ahead and multiply this fraction right here by e to the x over e to the x. We can do that because e to the x over e to the x, well, that's just 1. So then we have the integral of 1 divided by e to the x plus 2 times e to the negative x plus 2 multiplied by e to the x over e to the x dx. So once again, because e to the x over e to the x is 1, this is something that we can do. And this is a trick that usually works for integrals like this. Alright, so then what we have is the integral of 1 divided by e to the x multiplied by the denominator. So we have e to the x plus 2 times e to the negative x plus 2 times e to the x. So all I did is brought this e to the x right here. And then we have obviously our dx. We're not going to forget that. Alright, so now if we go ahead and expand the denominator, so we multiply e to the x with each term right here, e to the x times e to the x, that's just e to the 2x. E to the x times 2 times e to the negative x, well, e to the x times e to the negative x, that's just 1. So what we end up with is simply 2. And then we have 2 times e to the x, which is just that, 2 times e to the x. And then obviously we still have our e to the x right here with our dx. Now all I'm going to do is I'm going to rewrite this e to the 2x as e to the x squared. So I have the integral of 1 over e to the x squared plus, I'm going to simply write 2 to the ex here plus 2 times ex dx. Alright, now what we're going to go ahead and do is we're going to do some u substitution. So if we let u equal e to the x, then du is going to be e to the x dx. That's the derivative with respect to x of e to the x. So we can replace this e to the x dx with du, and every e to the x term we can replace with u. So what we end up with is, let me zoom in, we have the integral of 1 divided by, it's going to be u squared plus 2u plus 2 du. Alright, now so what we're going to do now is we're going to go ahead and simplify this even further. So if what you can notice here, u squared plus 2u plus 2, that's the same thing as, sorry, let me just fix my pen here. Alright, so that's the same thing as u plus 1 squared plus 1. Why? Because u plus 1 squared, that's equal to u squared plus 2u plus 1. We have u squared plus 2u plus 2, so all we have is to add another 1. So this right here is u plus 1 squared. So essentially we completed the square. So this is our new integrand right here. Obviously, let's not forget our du. And now the trick is a double u substitution. So in this case, we're going to use another variable. Let's say, for example, just an arbitrary variable, let's say v. So we're going to double substitute. So here what we're going to do is we're going to let v equal u plus 1. Then dv, the derivative here, is simply going to equal to, well, the derivative of u is simply going to be du. So dv is equal to du. And now this is really easy. So since v is u plus 1 squared, what you have is the integral of 1 divided by v squared plus 1 dv. And one of the core formulas here is you have to remember that this right here is just the arctan of v. This integral gives you the arctan of v. Remember, arctan of x prime, that is just equal to 1 over 1 plus x squared. This is the same principle applied here. So you have arctan of v, and v is u plus 1, so you have arctan of u plus 1. And then remember, we defined u to be equal to e to the x. So what you have is arctan of e to the x plus 1. And obviously, we're not going to forget our constants plus c. And this right here is the answer to this problem. Thank you guys for watching. Please like and subscribe if you enjoyed this video. And I'll see you soon for another video.